Welcome to the deep dive. Today, we're jumping into one of the most fascinating tech races happening right now. It's all about autonomous robotaxis.
Absolutely. A huge topic.
Yeah, and we've sifted through, well, a whole lot of material, technical deep dives, market reports, you name it, to really get to the heart of it for you. Think of this as your essential guide to the two main players duking it out, Waymo and Tesla.
That's right. And it's more than just tech, isn't it? It's a fundamental clash of philosophies. How do you even get to full autonomy? And maybe even more importantly, how do you build a real business out of it, a scalable one?
Exactly.
So we're going to unpack all of that. Their strategies, the hardware they use, the software, the data, how they plan to actually win this thing.
Okay, so our mission for this deep dive,
Yeah.
we want to equip you with a clear picture. Why does Waymo look like the leader today in terms of safety and proven tech? But also, why might Tesla's approach, the more radical one, be the real disruptor down the line?
Who's ahead now? Who has the potential for tomorrow? And what are the massive hurdles each one faces? That's what we're digging into.
And that core difference you mentioned.
Yeah, it's Waymo's really methodical, safety-first path to scaling up versus Tesla's, let's call it scalable path to safety, banking heavily on generalized AI. What makes them tick so differently? That's where it gets really interesting, I think.
All right, let's get into that foundational divide then. It really does seem to boil down to these two totally distinct worldviews.
It absolutely does. So on one side, you've got Waymo's thesis, the safest path to scale. This really comes from their Google X roots, that research background. The core belief is, prove true autonomy is safe, prove it's reliable, but do it first within a defined area. A geofence?
Like Phoenix or parts of SF.
Exactly. Master the really tough urban driving first. Show it works, demonstrably, safely. Then you expand. It's a classic engineering approach, right? Methodical, iterative. You see it in their safety reports, their cautious rollout. They've been running 204/7 for nearly 5 years now.
Building trust piece by piece.
Precisely. Building trust with regulators, with the public, based on performance data. For a business, yeah, it's slower, but it's arguably a more secure way to enter the market.
And then Tesla just throws a wrench in that whole model.
Yeah, pretty much. A complete counterpoint. Tesla's thesis. The scalable path to safety. Their whole bet is on generalized AI. The conviction is if you train a system on enough diverse data from millions of cars,
Their customer fleet?
their customer fleet, exactly, it can learn to drive anywhere, kind of like how humans learn from experience. So the goal is this single software solution that works everywhere, and then, flip a switch, activate a global robotaxi network.
Which explains the vision-only cameras, right?
Yeah.
Keep costs down, make every car potentially part of that network.
Absolutely. Quantity of data, low hardware cost for mass production. Every car off the line is, in theory, ready to go.
Okay, so these are starkly different starting points.
Yeah.
How does that translate into what they see as success or their biggest risks from a business perspective?
Well, Waymo's early success was just proving level 4 autonomy was even possible. The car drives itself under certain conditions, no human needed, and doing it safely. Their big business risk now, being too slow, too cautious. Maybe the economics don't work out if they can't scale faster because the upfront costs are so high.
They might get leapfrogged.
Potentially. Whereas Tesla defines success by getting that FSD-capable hardware out there everywhere. Scalable deployment, their nightmare scenario, the big risk, is a major safety failure. Something catastrophic that completely undermines trust in their vision-only approach and spooks regulators. That could collapse the whole strategy.
It really reflects where they came from, doesn't it? Waymo's patient research culture versus Tesla's drive for manufacturing scale and disruption.
Exactly. Their corporate DNA shapes everything.
Now, let's get tangible. How do these philosophies show up in the hardware? How the cars literally see the world. This impacts cost, scalability, everything.
Oh, absolutely. Waymo's vehicles, they're like multi-modal fortresses. Redundancy is practically a religion for them. They layer everything. Cameras, multiple types of LiDAR, radar, all working together for this rich 360-degree view.
So if one sensor struggles,
Another one compensates.
right?
Think blinding sun glare for a camera or maybe heavy fog for LiDAR. The Fusion approach handles that. Their previous generation car, the Jaguar I-Pace, had something like 29 cameras, 5 LiDARs, 6 radars, just packed with sensors.
Oh,
Yeah. Now, their newer 6th-gen system, the Zeekr vehicle, they've optimized it, brought the cost down, streamlined it a bit, 13 cameras, 4 LiDARs, 6 radars. But critically, they still have that multi-sensor redundancy. They even added microphones, external audio receivers to detect sirens. It shows how thorough they are about situational awareness.
So, maximum safety, throwing all the tech at it. Tesla famously went the other way.
Yeah.
The radical vision-only bet. Why? Was it purely cost?
Cost was huge, but it was also philosophical. The vision-only gambit, as some call it. The argument, pushed hard by Musk, was humans drive with two eyes, right? So advanced AI should be able to as well. LiDAR, radar. They were framed as crutches. Unnecessary, expensive.
Which obviously helps if you want every car you sell to be a potential Robotaxi. Lower bill of materials.
Exactly. It makes mass production feasible. So their current fleet on Hardware 3, or HW3, that's 8 cameras, ultrasonic sensors, originally a forward radar they later deactivated via software, all powered by their custom FSD chip. But here's where it gets really interesting. Hardware 4, HW4,
Right.
it marks a subtle but pretty significant shift. They've upgraded to higher resolution cameras, 5 megapixels. The FSD computer is way more powerful. And crucially, they brought back radar. A new high-definition Phoenix radar.
Wait, so not so vision-only anymore?
No. Well, they walked back the pure vision rhetoric a bit.
Yeah.
And to make vision work better without LiDAR, they developed something called the occupancy network. It's pretty clever. It uses the camera feeds to generate this real-time 3D map of what space around the car is occupied or free. It's like a software-based virtual LiDAR using just cameras.
So it feels like they're both moving towards the middle a bit,
Right.
Waymo optimizing costs, Tesla adding back sensors.
Precisely. It does look like a convergence. Waymo started with maximum overkill. Now they're getting leaner, more cost-effective with the 6th gen. They recognize those initial hardware costs were a huge barrier to scaling.
Makes sense.
And Tesla, after years of championing pure vision, they've added back radar, boosted camera resolution, implicitly admitting that cameras alone have physical limits, in bad weather or tricky lighting.
So the debate's moving beyond just LiDAR versus no LiDAR.
I think so. It's becoming more about finding that optimal cost-performance balance. Both are trying to engineer the most capable system for the lowest possible price point. It shows the industry is maturing, learning what's truly needed versus what AI can realistically infer. Practical engineering and economics are shaping the path.
Okay, so hardware is the eyes, software is the brain, how they think, how they decide. And this seems like an even sharper divergence, right? Two totally different bets on AI's future.
Oh, absolutely. This is where the philosophies really clash. Waymo's approach, you could call it an evolved modular pipeline. Traditionally, it was summarized as sense, perceive, predict, plan, or sense, solve, go. Distinct software modules handle different tasks.
Like one piece figures out what's there, another predicts where it's going, another plans the car's path.
Exactly. And that modularity is key for them because it makes testing and debugging much more rigorous. You can verify each component. That's critical when you need to build a safety case for regulators. A cornerstone of this is their reliance on high definition or HD maps.
Right, these super detailed maps.
Yeah, centimeter accurate 3D maps. They meticulously map out everything: lane lines, curbs, traffic signs, signals. The car uses this map as a baseline understanding of the static world. It simplifies the perception problem, letting the car focus its processing power on dynamic things, like other cars or pedestrians.
But that map dependence must be a constraint too, right?
It is a constraint for scaling, we'll get to that. But Waymo isn't standing still either. They are heavily integrating AI. They use things like graph neural networks for much better prediction of how road users will move. Transformer models, like in ChatGPT, to understand interactions. They're even developing what they call a Waymo Foundation model, trying to bring in concepts from large language and vision models for a more holistic understanding of the scene.
And simulation is huge for them too.
Massive. They call it CarCraft or a simulation city. They run billions, literally billions of virtual miles to test new software versions, especially focusing on rare, tricky edge cases you might seldom see in the real world.
Okay, so a structured, verifiable, map-reliant approach,
Yeah.
but increasingly AI-powered. And Tesla. You said end-to-end revolution. That sounds dramatic. What does E2E actually mean here?
It is dramatic. And a huge technical gamble. Tesla's pivot to an end-to-end AI model with FSD version 12, that was a fundamental shift. They essentially threw out something like 300,000 lines of explicit C++ code, all the handwritten rules for steering, braking, perception logic, replaced by a single massive neural network. Think about teaching a kid to drive. You don't give them thousands of physics equations, you show them hours and hours of driving, and they just learn. They figure out how to react, steer, accelerate.
So the AI learns directly from video.
Basically, yes. The model takes the raw video streams from the cameras as input, and its output is directly the vehicle control commands, steering angle, acceleration, braking. The goal is this generalized driving intelligence that emerges purely from processing billions of miles of driving data. It's not following specific if-then rules programmed by engineers, it's inferring the patterns of safe driving.
And the key enabler for that is not using HD maps.
Correct. That's deliberate. Tesla wants the car to build its understanding of the world in real time, purely from its sensors, like a human does. This is absolutely central to their scalability vision. If you don't need a pre-built map, then theoretically a Tesla can drive anywhere, even places it's never been before. That map creation and maintenance cost just disappears.
Wow. So it really is a fundamental bet on where AI is going. Is the bitter lesson of AI true for driving too? That massive data and compute just beat clever human-designed rules.
That is precisely the wager. Tesla is betting heavily that the bitter lesson applies here, that scale, massive data sets, massive compute for training will ultimately produce a better, more general emergent driver than Waymo's more structured, engineered approach. Waymo, coming from robotics, embraces AI, but they still prioritize interpretability, verification, explicit safety constraints. Even as they integrate more end-to-end components, that safety case thinking is core.
So it's not just tech, it's philosophy, and it's a regulatory gamble too.
A profound one. If Tesla's E2E approach works, and this is the huge if, they can rigorously prove its safety to regulators and the public, they could leapfrog everyone.
But if it stumbles on those tricky edge cases or can't satisfy safety standards,
then their whole scaling advantage based on this makeless E2E model could face major setbacks. Waymo's hybrid approach, while slower to scale geographically, is designed to be incrementally verifiable, building that trust block by block. It's a fascinating strategic divergence.
okay, let's talk data. The fuel for all this AI, again, totally different strategies here.
Completely different. Waymo's approach. Think curated data factory. Quality over just raw quantity. They use their professionally managed fleet, the robotaxis themselves, to gather super high-fidelity data from all those sensors, cameras, LiDAR, radar, but within those defined geofenced areas.
And they test specific scenarios.
Extensively. At their closed course, Castle, they replicate over 40,000 specific situations, including really weird edge cases, like the famous example of someone jumping out of a porta potty into the street. Things you need the system to handle, but hope it rarely encounters.
Right, preparing for the unexpected.
Exactly. And they use active learning pipelines. The system flags challenging or confusing situations it encounters in the real world, and those get prioritized for human review and potential retraining. They focus engineering effort on the data that offers the most learning value.
And the miles.
By March 2025, Waymo reported over 71 million fully autonomous miles, that's rider-only, no safety driver, plus over 20 billion simulated miles. So it's a deep, high-quality, verifiable data set focused on complex urban driving.
And Tesla, it's just data everywhere.
Pretty much, Tesla's strength is the unparalleled data ocean. The sheer scale is mind-boggling. Over 6 million Teslas out there globally, 4 million with the FSD-capable hardware.
That's a huge potential data source.
It's unprecedented. They get data from every imaginable road type, weather condition, driving culture around the world. A lot comes from shadow mode.
How does that work?
The FSD software runs silently in the background while a human is driving. If the software would have done something different from the human, braked harder, steered differently, it flags that interesting event and can upload the data clip for analysis and potential training.
So they learn from human actions or disagreements with human actions.
Right. Plus, feedback from the active FSD beta users. And they invest heavily in automated labeling. They can use data from multiple cars driving through the same area to build a very accurate 3D model of the scene, and then use that model as ground truth to automatically label objects in new data clips from that area. It helps them process the massive data volume.
The scale sounds incredible. They claim lifetimes of driving experience compressed into minutes.
Yeah, the claim is their fleet experience is the equivalent of a human lifetime of driving every 10 minutes or so. It creates this massive continuous feedback loop.
Okay, but data scale isn't everything. The crucial measure has to be safety, right? Especially if you're putting robotaxis on public streets.
Yeah.
How do they stack up there? This is vital for business reputation, regulation, everything.
Paramount question. And here, the approaches to transparency are also night and day. Waymo provides a very public, detailed safety scorecard. They publish reports, often collaborating with academics, outlining their methodologies very clearly. They compare their performance against a carefully adjusted human driver benchmark,
Adjusted how?
adjusted for the specific types of roads and conditions where Waymo operates. So it's a fairer comparison than just a raw national average. And their results. They report things like an 88% reduction in crashes involving any potential injury and a 78% reduction in crashes involving any contact compared to that human benchmark across those 71 plus million driverless miles.
And the data is public.
Crucially, yes. The raw crash data is available for independent researchers to analyze. That builds trust. It's a foundation for regulatory approval and public acceptance, absolutely vital for a viable service.
Okay, what about Tesla's safety claims? They put out reports too, don't they?
They do. Tesla publishes a quarterly vehicle safety report, and they consistently claim much lower crash rates for autopilot compared to the national average. Like one crash per 7.44 million miles on autopilot versus maybe one per 700,000 miles nationally.
That sounds impressive on the surface.
It does, but those figures are widely criticized by safety experts, by statisticians, by NHTSA itself sometimes. The main criticisms are a lack of transparency in the methodology and that it's often an apples to oranges comparison.
How so?
Critics argue Tesla compares autopilot performance, which is predominantly used on limited access highways, statistically much safer roads, against the national average crash rate for all road types, including much more dangerous city streets and rural roads where autopilot is used less or not at all.
So, potentially misleading statistics.
That's the accusation. Plus, unlike Waymo's driverless miles, Tesla's figures are for a system that still requires driver supervision. And we know Tesla's systems have been involved in numerous crashes, including fatalities, leading to multiple ongoing NHTSA investigations. That creates significant regulatory friction and public relations challenges.
It really comes back to that long tail problem you mentioned, the rare, tricky events.
Exactly. Waymo tries to curate the long tail. They actively seek out, simulate, and test for those rare edge cases. Build a verifiable safety case. Tesla's approach is more like trying to drown the long tail with data. Hope that by seeing billions of miles, the neural network just implicitly learns how to handle everything.
One feels more provable. The other relies more on faith in the AI's learning.
That's a fair way to put it. One is designed for certification, the other relies on emergent behavior, which is inherently harder to fully validate and prove safe to skeptical regulators and the public.
Okay, so we have the tech, the data, the safety picture. Let's talk business. Turning this incredible tech into a working, profitable service. Again, very different paths.
Radically different go-to-market strategies reflecting their core business models. Waymo's strategy is methodical, just like its tech development. Focus on key, high-value urban markets and build a defensible position there. They're operating Waymo One, their ride-hailing service, in Phoenix, San Francisco, LA, Austin. The playbook is consistent. Map the city thoroughly, test with employees, launch a trusted tester program for early riders, then open to the public.
Step by step.
Step by step. Their recent partnership with Uber in Phoenix, offering Waymo rides through the Uber app, shows they're also looking at B2B channels to tap into existing demand.
And the fleet size.
Growing steadily. Over 1,500 vehicles now, plans for 2,000 more soon. They're even doing initial testing over in Tokyo. It's tangible progress, accelerating, but still quite deliberate and geographically limited for now.
Deliberate expansion.
Yeah.
Tesla, on the other hand, seems geared up for, well, a blitzkrieg if they can flip that switch.
That's exactly the design. Near instantaneous activation once they believe the tech is ready for unsupervised operation. After years of, let's be frank, missed deadlines and promises, they did launch their first official Robotaxi pilot in Austin, Texas in June 2025.
Okay, that's a milestone, but how real was it?
Well, it was very controlled. A tiny fleet, maybe 10, 20 Model Ys, strictly geofenced. Access was highly curated, influencers, investors, more symbolic than a large-scale service launch.
But the long-term vision is much bigger.
Oh, vastly bigger. The dream is the Tesla network. The idea is that any Tesla owner whose car has the final unsupervised version of FSD can choose to add their personal car to a shared robotaxi fleet when they aren't using it.
Like an Airbnb for cars.
Exactly.
Yeah.
Tesla provides the platform, connects riders with cars, and takes a cut. This would allow them to scale their robotaxi fleet almost overnight, potentially to millions of vehicles, by leveraging assets customers have already paid for. It's incredibly capital efficient in theory.
Okay, let's talk brass tacks. The economics. How do the numbers look for these two vastly different models, especially for investors?
Yeah, the economic equation is stark. Waymo's biggest hurdle is the massive upfront capital expenditure, the CapEx. That complex sensor suite, LiDAR, radar, high-end compute makes each vehicle very expensive. Those fifth-gen Jaguar estimates were well over $120,000 per car, maybe $150K, $200 all in initially.
That requires deep pockets.
Billions from Alphabet, yes, Google's parent company. Their Other Bets division, which includes Waymo, consistently reports substantial operating losses. Now, they are working intensely to bring costs down. That sixth-gen Zeekr vehicle is supposed to be significantly cheaper to produce, and they project operational costs, the per-mile cost, could get as low as 0.30 cents.
And how do they price it?
Currently, they price rides at a premium, especially in SF. They can leverage the novelty, the perception of safety, and advanced tech. Their business model looks multifaceted. Direct rides, Waymo One, partnerships like Uber, and maybe even licensing their tech stack eventually.
Okay. And Tesla's grand economic vision, built on that low-cost hardware.
Entirely. Their whole thesis relies on a radically lower cost structure, using standard production cars, ditching expensive LiDAR. The hardware cost per unit is a fraction of Waymo's, that's the foundation. Analyst projections for Tesla Robotaxi operational costs are often in the $25 to $0.40 per mile range, similar to Waymo's target, maybe even lower eventually.
And the pricing strategy, that Austin pilot had a weird price.
Yeah, the $4.20 flat fee was pure publicity stunt, obviously. But the long-term vision is aggressive, dramatically undercut existing ride-hailing like Uber and Lyft. Offer rides potentially around $1 per mile, maybe even less. The goal isn't just to compete with taxis, it's to make robotaxi rides so cheap they challenge the economics of owning a personal car altogether for many people.
So it's not just a taxi company, it's a platform play.
Exactly. That's the key difference for valuation. The model is this hybrid. Some Tesla-owned robotaxis, maybe the cybercabs, alongside this huge decentralized network of customer-owned cars earning money for their owners. Tesla takes a commission, like Apple on the App Store. The car is the hardware, FSD is the operating system, the network is the marketplace. That generates high-margin, recurring software revenue.
Which is why the valuation discussion around Tesla often seems detached from just car sales. It's this potential future platform value.
Precisely. A potentially multi-trillion-dollar recurring revenue software business layered on top of the hardware sales. It's fundamentally more scalable and, if it works, vastly more profitable than just operating a fleet of taxis yourself.
Okay, but there's a massive elephant in the room for both. Regulations. The regulator gauntlet seems like it could make or break either strategy.
It's absolutely critical, maybe the single biggest factor controlling the pace of deployment. And here again, different approaches. Waymo has consistently pursued a strategy of deep collaboration and transparency with regulators, state, federal, local. They proactively file for permits, submit incredibly detailed safety plans, maintain constant open dialogue, they share data.
Building that trust you mentioned earlier?
Yes, and it's paid off. It built significant credibility, allowing them to get approvals for expansion, for removing safety drivers, even in cautious states like California, sometimes while competitors were facing suspensions or roadblocks.
And Tesla.
Tesla has, well, a more contentious relationship with regulators.
Yeah.
Those ongoing NHTSA investigations into crashes involving autopilot and FSD are a major factor. Their whole full self-driving beta approach using paying customers to test and validate safety-critical software on public roads drew enormous criticism from safety advocates and regulators.
Seen as less transparent.
Generally perceived as less transparent and more confrontational at times. This regulatory friction is a very real, significant hurdle for their plans of a rapid nationwide robotaxi rollout. It directly impacts the business timeline and risk profile.
So, pulling it all together, who can actually scale this? Who can win the world? This scalability dilemma feels like the absolute core of the competition.
It really is the crux of it. Let's look at Waymo's scaling challenge first. It's largely about physicality and precision engineering. They don't mass-produce cars themselves. They partner with OEMs like Jaguar, now Zeekr. Ramping up a fleet to hundreds of thousands, let alone millions, requires huge capital investment, complex global supply chains, and the intricate process of integrating their custom sensor suite and compute into each vehicle.
Their production rate is just inherently lower than Tesla's.
Dramatically lower. Tesla makes millions of cars a year. Waymo's fleet is measured in the thousands. And then there's the HD map dependency. While great for reliability in known areas, it's a bottleneck for geographic expansion. Mapping a new city is time-consuming and expensive, and you have to constantly maintain those maps as roads change, construction happens. It's a perpetual operational overhead across every city they operate in.
So the rollout is fundamentally city by city, block by block.
Yes, methodical and slower. Each new city or expansion zone needs fresh mapping, testing, validation, regulatory engagement. It takes months, sometimes years, plus logistics like charging infrastructure for a large fleet.
Okay, so Waymo's challenge is scaling the physical operation and overcoming map limitations. What's Tesla's scaling challenge? If they can build millions of cars, what's holding them back?
Tesla's scaling challenge is fundamentally different. It's about unsupervised reliability. It's an AI problem. Their entire scaling advantage, the mapless approach, activating customer car, it's all theoretical until FSD is proven safe and reliable enough to operate with no human oversight. Level 4 or 5, autonomy, truly driverless.
And the big question is, can their AI approach get there?
That's the multi-trillion-dollar question. Can their end-to-end data-drowning approach truly conquer the long tail of infinite edge cases? The weird, unpredictable stuff that happens on the road? Critics worry about diminishing returns. Just adding more billions of miles might not be enough to solve those final, hardest 0.01% of scenarios. It might require fundamental changes to the AI models, maybe even hardware upgrades like better sensors.
Which could make millions of existing FSD-capable cars obsolete for true robotaxi use.
That's the risk. If HW3 cars can't actually achieve unsupervised FSD, their biggest scaling lever activating the existing fleet vanishes. And ultimately, proving that safety to regulators is the absolute gatekeeper. Given the ongoing probes, the documented struggles, that's a monumental task. One high-profile, catastrophic failure of an unsupervised Tesla could be devastating for public trust and trigger harsh regulatory crackdowns, setting the whole vision back years.
But the physical fleet advantage is real. They can make the cars.
Undeniably, Tesla's manufacturing scale for the vehicles themselves is unmatched in this space. And yes, they have millions of cars already on the road that could theoretically become robotaxis with a software update. The core question isn't, can they scale the hardware? It's, can they scale the autonomous capability to be truly driverless and provably safe? And this brings us right back to that central point. Which problem is harder to solve? Waymo faces complex, expensive, but ultimately known engineering, logistical, and economic scaling challenges, solvable with enough capital and execution. Tesla faces an unsolved research and development problem at the bleeding edge of AI. Can generalized AI truly master driving safely in all conditions? One is about incremental progress and operational excellence. The other is more binary. It requires a breakthrough. Or it might hit a wall.
Okay. So after this deep dive, hardware, software, data, business, scaling, what's the final verdict? Waymo versus Tesla in the robotaxi race. Where do things stand now, and where might they be heading, especially for our audience thinking about the market implications?
Yeah, it's definitely nuanced. You can't just declare one winner easily. Today, right now, in terms of proven technology and demonstrable safety, Waymo is unequivocally superior, no question. Their multi-modal hardware provides robustness. Their software stack is mature, validated over millions of driverless miles. Their safety data is transparent, shows significant crash reductions, and is building regulatory trust. Their business is real. They're giving hundreds of thousands of paid rides every week in multiple cities.
Okay, Waymo leads today on proof points.
But for future scalability and sheer economic potential, Tesla holds a profound theoretical advantage. It's undeniable. Their low-cost hardware approach, the mapless architecture potentially allowing infinite geographic scale, the incredibly capital-efficient business model leveraging customer cars. It offers a path to global deployment and a high-margin software platform that Waymo, with its current approach, just cannot match in speed or cost structure.
So it really is a race for each of them to plug their biggest strategic hole.
Exactly. Waymo needs to solve its cost and physical scaling problems. These are hard, expensive problems, but they are fundamentally engineering and business execution challenges. They seem solvable, albeit maybe slowly. They're making progress. The 6th-gen hardware is cheaper, operations are getting streamlined. Tesla's challenge is far more uncertain. They need that fundamental AI breakthrough for true unsupervised driving. And it's not guaranteed. AI progress is stunningly fast, yes, but achieving that last bit of reliability for safety-critical systems is notoriously difficult. That breakthrough remains a huge variable.
So looking out, say, 3 to 5 years, Waymo likely defends its lead in those premium, geo-fenced city markets.
That seems probable. Their lead there looks defensible in the short to medium term. They can continue to expand city by city, refining the service, maybe lowering prices gradually.
But the longer-term picture, 5 years plus, that hinges entirely on Tesla's AI progress.
Largely, yes. Can Tesla crack the code for unsupervised FSD? And critically, can they convince regulators and the public that it's safe enough for widespread deployment? If they can, their scaling advantages could let them dominate the mass market. If they can't, they might remain stuck in driver assist or limited robotaxi deployments.
And it's probably not winner take all.
Unlikely. The potential market for autonomous mobility is absolutely enormous, trillions of dollars globally. There's likely room for multiple players with different strategies, maybe focusing on different market segments. And we'll probably see more convergence too. Waymo will keep pushing costs down. Tesla might face more pressure, maybe from regulators or as reality, to add more sensor redundancy, like they already did with radar and HW4. Both are optimizing.
And the ultimate kingmakers, the ones who really control the pace.
Regulators,
Yeah.
without a doubt. Their comfort level, their standards, how they interpret safety data, how they respond to incidents, that will dictate how fast and how broadly each company can deploy. And in that arena, Waymo's collaborative, data-driven, transparent approach currently gives them a significant edge. It provides a much more stable foundation for gaining regulatory approvals for expansion. Tesla's path there looks rockier.
So here's something for you, our listener, to really chew on. We have Waymo building this verifiable, safety-first, incrementally improving system, and we have Tesla betting big on an emergent, breakthrough AI that learns from data at massive scale. Which approach do you think is more likely to ultimately win widespread public trust? Which one will convince regulators? And which one will truly dominate our roads in the long run? It's a fundamental question about how we integrate this powerful AI into the physical world and reshape transportation as we know it. Thank you for taking this deep dive with us today. We really hope you feel much more informed about this incredibly complex and fascinating race.